exercise 8D, which is looking at rules for the nth term in a sequence modeling linear growth or decay. So in the past, we've realized we can create these sequences, and you can go through and find out what's happening after the first year, go ahead and work out what's going on the second year, and so forth and so forth. That's all good. If you've got like 4 or 5 years, you can work out each of them and go on from there. But things get a bit more challenging if you were asked to find out what's happening in the 50th year or the 100th year. It would take a long time to have to work through each of those years. Using the following recurrence relationship modeling. Yep. So this is what it's basically saying here. If you had an investment of $2,000 in simple interest, paying 5% interest per annum, and you invested in investment increased at the same amount, $100 each year, it's basically saying, okay, well, here's a linear recursion relationship model for that. So the starting value is 2,000, the principal amount you invested. It's saying each year, you're adding $100 on. Yep, that's increasing by the same amount. Yep. Again, you could, as we show here, show what's happening after each of the years. That's cool. However, there is a pattern that starts to exist, and it says after a certain amount of years, you could write it as Vn equals 2,000 plus n times 100. Yep. So the good news is, if you then had to work out what's happening after 20 years or 30 years, rather than having to work through the pattern, you can just apply it after n years. Yep. So it's a lot easier. So the good news is there is a recursion relation formula to do this. It says here the recursion relations rule is as follows: V0, the initial amount, the next value is equal to the current value plus d. When you have this type of setup, which we were looking at in the previous one, where you're adding on that constant value, to find the nth term, so any number term generated by the sequence, you do use the following models if it's growing. So if things are going up, Vn is going to be equal to the initial amount plus whatever n is multiplied by d, the constant that's going up. On the other hand, if it's going down, linear decay, it's going to be the initial amount multiplied by however many times the n value is by d, the constant there. This is the one that I would definitely be writing down in your notes. For simple interest investments and loans, obviously that value gets added on. Yep, it's going up. So here you notice it's adding on n times d. Now for simple interest, that d value, and we've spoken about this before, is equal to the rate divided by 100 multiplied by the initial value. Now, if you were to write out the whole thing as simple interest, what they've done is, rather than writing out this part and this part separately, they've rewritten this d part into the equation here. So writing it down full, Vn is equal to V0 plus n times this part here, r over 100 multiplied by V0. Okay, so these are all the same things. That's just put into there. It's written it out in full. Depreciation works the same, except obviously values are going down. So you're going to be subtracting n times d. D is the same thing again. You can see it all written in full. One of the other things that you do need to make a note of is what's called unit cost depreciation. And it says here, there's a rule for unit cost depreciation. You'll have an example of this in a moment. V0 is the initial value of the asset, which is, we find how much the cost was originally. And it says let D be the cost per unit of use. And again, the value of the asset after n uses or n units of use is going to be given by this depreciation formula here. Alright, a little bit to get your head around, but please follow along as we're going through this. It says, use a rule to determine the value of simple interest investment. This is example number 1. It says the following recursion relationship can be used to model a simple interest investment. Cool, so V0 is equal to 3,000. The initial amount they started off with the investment was $3,000. Yep. And they're saying that the next value in the investment is equal to the current value plus 260 there. So it's going up by 260 each time. Yep. And it says where Vn is the value of the investment after n years. Cool. So you can go and find out what's happening after, say, 3 years by substituting n equals 3 into there to get that happening. Alrighty, so it says here, these are the questions it's wanting us to answer. What is the principle of the investment? We've spoken about this before. The principle of the investment is the initial value that starts off with. In this case, it is $3,000. Cool, happy days there. The next part of the question was how much interest is added to the investment each year. So as we can see from this recursion relationship, the D value, the constant that's going up each year, is 260. So the amount of interest that is being paid each year is $260. Next it says write down the rule for the value of the investment after n years. So again, remembering what I just said in the previous page, the rule for increasing values after for simple interest investments of loans after n years, this is the formula here. Vn equals V0 plus n times D. Yep. And in this particular case, we're going to substitute in what we know V0 was, the starting value, which was 3,000, and we're going to substitute in the D value, which was 260. Yep. Now, obviously, when you're writing it out, it would be Vn equals 3,000 plus n times 260. Rather than writing n then times 260, we just know that's the same as 260 times n. Okay, you can swap those around. So that is the rule there to calculate the investment after n years. So any amount of years, you can tell me, hey, what's happening after 20 years? We can figure it out because we've got this formula now. Indeed, the next question was saying, hey, use that rule that we just found out to find the value of the investment after 15 years. Cool, so the n value is 15. What we're going to do is write out this again, but we're going to write in where n is, we're going to write in 15 and calculate it. So V15 is going to be equal to 3,000 plus 260 times 15. And we can find out that after 15 years, the investment is going to be worth $6,900. And again, hopefully you're realizing it's a lot easier to use this particular format rather than working out one of them, then the next one, and doing that 15 times. Yeah. Last bit, it says use a rule to find out when the value of the investment first exceeds $10,000. Okay, so this one, we know that the investment is 10,000, so we're going to write where Vn is, we're going to substitute in 10,000 of the rule. So when 10,000 is equal to 3,000 plus 260n, ultimately we're trying to find out what n is. Yep, to find out how long it's going to be. Yep, when it first exceeds that 10,000. So it's about rearranging things. Yep, so you got $3,000 here. You need to move that over to this side because ultimately we want to find n by itself. So take away 3,000, take away 3,000. You end up with 7,000 equals, and you're left with 260n on the right hand side of the equation. From here, to get this n by itself, currently it's multiplying by 260. We need to do the opposite, which is to divide this side by 260. What you do to one side of the equation, you have to do to the other. So we're going to do 7,000 divided by 260, and that will tell us what n is. In this case, it is 26.92 years. Now, it says here, because interest is only paid into the account after a whole number of years, any decimal answer will need to be rounded up to the next whole number. Okay, so they're not going to get that amount, 10,000, until after the 27th year. Yep, so you need to make sure of that. Up until 26.92, you're not going to have got to that stage yet. Alrighty, next example. It says here, use a rule to determine the value of simple interest, part 2. Oh, it's Amy. Spelled A-M-I-E. Cool. Amy invests $3,000 in a simple interest investment of paying an interest rate of 6.5% per year. It says use the rule to find the value of the investment after 10 years. Alrighty, so this is where we're going to use the big version of this formula. Yeah. So writing out the formula neatly, we're going to plug in the values that we know. Yep. So V0 was the initial amount that Amy invests. It was $3,000. We want to know what's happening after 10 years. The value of n is 10. Also, the rate is 6.5%. Yep. And again, that gets multiplied by the initial amount, which was 3,000. Plug this into your calculator and you get the answer is $4,950 is the value of the investment after 10 years? Perfect. Like that question. Alrighty. We've had the chat about the ones where things are increasing, so there's linear growth going on with the simple investments. However, the other way is depreciation. Yep. Indeed, this one is flat rate depreciation, and the formulas were in the front of the book, front of this chapter. So it says here, the following recursion relationship can be used to model a flat rate depreciation of an office furniture. Cool. So V0, the initial amount of the furniture is $12,000. And it's saying every year it's going down $1,200. It's decreasing in value $1,200. So just even that sort of answers what I've said here in the first part. What is the initial value of the furniture? As I said, it started off V0 at $12,000. Yep, it must have been a really, really nice, comfy office chair. And every year it's asking what it decreases in value. It's going down $1,200. So the depreciation each year is $1,200. Next it says write down the rule for the value of the investment after n years. Again, you go to the bubble box that was in the front of the book, and we're writing out the rule, the general rule for depreciation or decreasing linear or linear decay. Yep, which is this one here. Vn equals V0 take away n times d. We're going to plug in the values that we know. We know V0, which was the initial amount, and we know what it's going down by, the D value. It's going down by 1,200 or 1,200. Now again, as I said the other day, just a minute ago, $12,000 take away n times d is the same as d times n. So we write out the d value first. Take away 1,200, which is depreciation times n. Yep, it's the same thing whether you write n times that or that times that. But that's how we write it in maths. Yep. So that's the general rule there. Vn equals 12,000 take away 1,200 n. Part C is saying use the rule to find the value of the investment after. It's not really an investment. I'd say find the value of the furniture or the depreciation of the furniture after 6 years. Yep. So in this particular case, you're going to be finding out V6. N is 6. So we're writing out the equation. Where we've got N in the equation, we're going to substitute in 6. We find out that the furniture is worth $4,800 after 6 years. Next it's saying, this question pops up a lot with depreciation. Yep. It's saying how long will it take for the furniture's value to decrease to 0? And often they'll want to know when its value is 0, because then when something depreciates in value and it's worth nothing or 0, things get written off as being no longer worth any money. Yep. So you may have heard of furniture or assets getting written off after a certain amount of time. Yep. Often cars will depreciate in value until they get written off when the value is 0. So what we do is we write out the equation, the general rule, and we're making it equal to 0. So essentially we're trying to find out what n is when this equation equals to 0. So again, it's a matter of rearranging things. You could use your calculator and type in the equation, solve, and write out the equation and get a calculator to solve it for you. Or you can use algebra skills to do this. Move this $12,000 over to here, and then obviously divide by 1,200 and then multiply by -1, and eventually you'll rearrange it and you'll get that n is equal to 10 years. Yep. So that means that the value of the furniture will depreciate to 0 after the 10 years. It says here a photocopier in the office costs $6,000 when new. Cool. Its value depreciates at a flat rate of 17.5%. So what is the value after 4 years? Okay, in this case, again, we're going to be writing out the big rule. Yep. So initial value of the photocopier was 6,000. V0 will be 6,000. We want to know what's happening after 4 years. So n will be 4, and it's decreasing at a rate of 17.5. Yep, so 17.5 will be there, multiplied by, again, the initial amount, which was 6,000. So again, it's just a matter of pulling these things up, plugging them in, and evaluating what it is. Turns out the photocopy will be worth only $1,800 after it's been used for 4 years in this particular case. Cool. One more question. Excellent. We're nearly there. Oh, look, there's a picture of the furniture. Yeah, not that expensive chair there. All right. What's this one? Oh, it's the hairdresser question. Cool. Example 15 says use a rule to determine the value of an asset with the unit cost depreciation. Cool. It says a hairdryer in a salon was purchased for $850 and the value of the hairdryer depreciates by 25 cents for every hour it is in use. Let Vn be the value of the hairdryer after n hours of use. Alrighty, so again, we need to, it says identify the initial value, V0, and also the D value, how much it's depreciating each time. Turns out the hairdryer was $850. It was a very good one for perfect hairstyling. So it started off at $850. And it's going down in value at 25 cents every hour. So we're writing that at 0.25, 25 cents. Writing it out as an equation, it's using the depreciation formula. So Vn is going to be equal to V0 take away ND. And so plugging those values in, we get this here. 850 take away 0.25 N. Cool. It says, what is the value of the hairdryer after 50 hours of use? Cool. So good news is we've just worked out the rule to find out the value after n hours. We're going to substitute 50 in to find out what it's worth. So after 50 hours of use, plugging n equals 50 into the equation, ultimately we'll be finding V50. Plugging it in, 850 take away 0.25 times 50. It brings the value of the hairdryer down to $837.50. Yep. So you can see it has decreased in value. Everyone should be pretty happy doing that. Next one says, on average, the salon will use a hairdryer for 17 hours per week. It's asking how many weeks will it take the value of the hairdryer to halve. Okay, so what you need to think about here is actually what half the original value is. So original value was $850. Halving the value would be $425, half of that 850. Yep. So ultimately we're going to be finding out when Vn is equal to 425. So we're going to have Vn as being 425, writing out the rule, 850 take away 0.25 n. Ultimately, we're trying to find out what n is, rearranging, and we get n is equal to 1,700. Yep. But because we're using it for 17 hours each week, what we need to do is actually divide it by 17 to get the number of weeks, was what they wanted the question here. So dividing this by 17, it's 100 weeks.